Good morning, chat. My name is Penbu. I'm the programming, puzzle gaming, and music making VTuber on Linux, and today we are programming. Doing another one of these cursed programming streams where we take some sort of unreasonable restriction and work with it. Lavani, welcome in. Also, 539, welcome in. Lavani, I still have to. I saw you posted the that spin the wheel video. Very interested. Still gotta watch that though. Maybe after the stream. 539. I may have insisted too hard on finishing the Lego typewriter in one sitting. Did not get much sleep. Yeah, I can relate. But seeing the pictures you posted elsewhere, it did seem like it turned out pretty well. So, yeah, pretty impressive. So today, we are going to do something that I call object horror, where the only thing that we're allowed to use is the object constructor. Plan right now is that we're going to be doing Hello World and FizzBuzz. Hello World is going to take much longer than I probably think it will, just because the challenge says that, I'm going to make this a little bit bigger, the only non-derived value we can use is object. And everything else that we use has to be derived from object. That means we don't get strings, we don't get numbers, we don't get arrays, we don't get all this nice stuff. We also don't get the usual functions like console logs. We're gonna have to figure out how to get right to the console. We can derive values from it. So certain things like property access and whatnot, we can still do. So we'll find some way to find these values, but we will have to dig for it a little bit. Well, that's basically it. If you know about esoteric programming languages, there is this language called JSF, where you only need to use 6 characters: the square brackets, the round bracket, round parentheses, and exclamation mark and plus. We're not going to go this far. But we will be using some of the ideas from it. Thankfully, our challenge here today is a little bit easier, but it's still going to be a bit of a challenge. So hopefully you don't get lost, and if you do, let me know and I can try to explain things. For those of you on Twitch, the repo is here with the challenge rules as well. For those of you on YouTube, it's all in the description. Let's see if I can figure out how to pin this. Twitch tends to have this problem where sometimes it just doesn't want to pin things. But there we go. That should do it. Okay, well, let's get started. Hope you're all doing well, by the way. So I'm going to start with Hello World. And we're going to see where we are. We're going to see how long this takes us. It starts hello world.js. We can begin with a function here, so I'm just going to do module.exports, just so we can actually run this thing. This equal to something, and then we're going to use a function hello, and then we're going to write our stuff in here. So this right here is where we're going to do our stuff, and we are restricted to just using object. So what do we need? Actually, let's start off first with an explanation of how we can get these values. I'm gonna go here. Right. So first off, we have the object constructor. It is a function. We can use the type of operator to get certain strings out of it. So type of object is a function. So we can use this string here. We can do object like so, and we get undefined. We can do plus object, and we get nan. I don't know if that's going to be any useful, but we can do not object, and we get false. We can do not object, and we get true. We can also do plus not object, we get 0. So here we're turning this into false. And then the plus means that it coerces it to a number. So we end up with false gets coerced to 0, And then we can do something similar where we have not, we get 1. And from there you can kind of tell how we can get the rest of the numbers. It's going to be a little bit cumbersome, but we can at least get numbers from here. Now the question is, how do we get letters? Because we're going to need letters. That is going to be a bit of a challenge here. So for example, if we want to get the letter F, one thing we can do is type of object so that we get the function string. And then we do property access where we do we take our number 0 and we do dynamic property access on this. We get the character at index 0, and that's F, because that's the first character here. And we'll see later on if we need to actually no, we're going to have to get, so to be able to get console log, we're going to have to find a way to get the function constructor, and we're going to have to do return console, and we're going to have to run it. And so now we get console from here, or something like that, right? So we're going to have to do some eval coding here to be able to get other objects. So this part is probably going to take up the most of our time. We're going to have to find a way to build the string here. And then from there, you also build, you can build console.log, I guess. And then we're going to have to execute that with hello world. Like so. So that's what we're going to try to work towards. We're going to find a way to get the function constructor, which hopefully we can figure out how to do. But yeah, we're going to start off with object, right? So this is our start. Actually, maybe, no, we're going to print it, because the other option we can do is return, but that almost feels like cheating. That simplifies things a little bit too much. The rules do allow us to put things into variables to just make things a little bit easier. So const 0 is equal to plus not object, as we saw before. Const 1 is this. Are we going to be able to do anything with this? Possibly. So if we look here, what do we need to make? We can get n. We're going to need that for console log. We can get O. We can get that for console log 2. So let's start off with those. Actually, I might do that over here so we have a node thing to work with. So const n is equal to type of constructor function. Type of object that, just so we can save that string somewhere. So now we have stir function at, I don't know, what is this? 0. That's not correct. Type of object. So 0, 1, 2. So we can add 1 twice to get there. So that's 1 plus 1. And now we get our letter n. Just for debugging purposes, we're going to log things out like this. And I think I will put that over here. We can run things. Nodes. And then we're going to do let's hello equals require hello worlds. We should see n here. Okay, good. So we do have n. We also want to get o. So that we can do with also the function. So that's 0, 1, 2, 3, 4, 5, 6. And so we are going to want to do a little bit of math here. Stir function. What's an easy way to get there? We could do. We could just add 1 6 times, or we can do 2 is equal to 1 plus 1, and then const 3 is equal to 1 plus 2. Const 6 is equal to 3 plus 3. What are our goals with these specific letters? So actually, yeah, that's probably a good point. I can make comments for this one. We're trying to build console log. Build console log as a string. So we're going to start with that. There are more letters that we're going to need, but we can start with that. So we have an N, we have an O. What else can we get from here? I think that's all the ones we can get from here, although... No, that's not quite right. Oh, but you know what else we can do? We can maybe try to figure out how to do this. Because now we get a bunch more letters. But we can't use the empty string literal, so we're gonna have to do something else for that. What else can we get from the object constructor? Object, being a constructor, does have a constructor function, and this is the function, like the function constructor, meaning this here. Which means this is our eval. However, to get this, we need to build a right constructor. So actually, that's probably where we should start. So we need to build a right constructor. We have an N, we have an O. We can get a T. Function, this is... So first of all, we get build constructor to do object constructor. Like that. This gets us a function, which we can use for eval. Then we get console logs so we can do stuff in there. Okay. So T 0, 1, 2, 3, 4, which we don't actually have a 4, but we can make 4 pretty easily. Const 4 is equal to 2 plus 2. And then just to make sure that we're actually console.log, make sure that we actually do have our T's and stuff all correct. We can do that again. Require. No, that's the wrong one. Nodes are hello world.js. I think that's hello? Okay, no, that doesn't work. Type of object gives us more letters. Oh yes, that's right. Because we can actually call the object constructor. The object constructor will give us an actual object. like so. So then type of object gives us object. No, new is redundant, so we can just leave that. What letters can we use from this one? We have the O again. We have the B, which doesn't really get us to anywhere here. We have C. C is very important, but we already have C from function. That's fine. We do get an E, which we will need for console. So we're going to do stir object is equal to type of object called, and type of object is string, yes, which will also be very useful. Just not quite sure where. And then if we chain more type ofs, then that'll just end up giving us more strings. But from object here, then we can get E. Const E equals stir object. If I can actually spell this right, just like that. That is 0, 1, 2, 3. Okay, that gets us that. Let's hello require hello world. Okay, so that gives us T as we expect it to. I think we can probably assume that all of these just work. Actually, I'm going to open that over here. Set it down here, so it's going to be a little bit easier to see. Or keep around, rather. Okay. So we can get E from this. Nodes. What other letters are we missing? We need an R, which we can get from the string. So if we did type of object, that gets us string. We can grab an R from there. Const string is equal to type of object, and we can do const R is equal to stir string at 2 0 1 2. Okay. What letters are we missing? Do we have a C? We do not have a C. But we can get C pretty easily from function. So const C is equal to stir function. This is 0 1 2 3. And then TU, we need a U from somewhere. We can get that from function. Const U is equal to stir function 1. So we almost have everything. We do need an S, which we can get from string. Const S is equal to stir string at 0. Do we have an O? We do have an O. So I'm going to format this a little bit differently. And instead, we're going to do this so that we know what we're missing. So S, we have an O, and we have an N, we have an S, T, R, U, P, T, O, R. I think we can actually spell constructor now. And just to make sure that we can, we need a console log C plus O. There's an easy way to do this. constructor. I might actually use that name. There we go. And just to make sure that you actually can. Cannot find module hello world. What happened? Oh right, because I need to PD. Actually no, this one is fine. We're gonna leave that one as is. This one is the one we're going to do. Let's hello. Okay, great. So we have constructor. Const okay. As much as I would like to do the rupture thing, the Hungarian notation means that it doesn't work as well. Okay, so now we have constructor, which means we can do const f or function is equal to object constructor. So now that we have we now have an eval that we can work with. So this is good. This is good. Now we build console log so we can get console log. Are we missing letters? Yes. We have C, we have an O, N, S, O, we do not have an L. Wrong variable name. Third constructor, yes. Thank you. We need to get an L from somewhere. Now object.constructor, if we do a type of, actually a type of that isn't going to give us anything because it is just a function. We do have a bunch of strings that we can use, which means it doesn't actually matter. We just need to find an L somewhere. Where can we find an L? Alright, what else is in the object prototype? And here we can look up the docs. We have value of toString. Actually, we can't even access any of these yet. Null, which we don't have, because we don't have L's. Ooh, actually. We have numbers, which gives us more letters, but none of those are L's. However, we do have booleans. Boolean has an L. So I'm going to do const bool false equals this. Const bool true is equal to this. And then we can rewrite these as these. Okay, so now we have our booleans. We can do const boolean is equal to type of bool false. Doesn't really matter which one we pick. Or we just do it that way. And so then this gets us const L is equal to 0, 1, 2, 3 stir boolean 3, like so. So now we have an L. We have an E, and now we just need a G. I don't think we've encountered a G yet somewhere. So number, Boolean, type of... That's an object. And even object plus string. There's no G in there. Oh yes, you're right, end of string does have a G. Okay, so we can do that. Const G equals string, and that would be 1, 0, 1, 2, 3, 4, 5. We can define 5 here as 4, 2 plus 3. Or it can be 4 plus 1 or whatever, it doesn't matter. Okay, so now we have a G. So now we can build console log. Oh, except we don't have a dot. We need a dot. Actually, that's fine. We don't have to use a dot. But we do need to also build... we need to build return. We do need to build return. Because this is function and not eval. Which means it has to return something. Okay. We have E, we have... oh, sorry, we have R, we have E, we have T, we have U, and R and N, so we can actually build return. We need a space. Which we can get from here. So const stir object type of, or object plus stir function. Doesn't really matter. Doesn't matter which string it is. And so this should give us object plus type of object is this thing. Then we just need to select the space here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. The const space is equal to stir object at 9, which we don't have 9 yet. But 9 can be easily constructed with const 9 is equal to 6 plus 3. Okay. So just as a sanity check to make sure that we are where we are, console.log what is it? Space. I suppose it doesn't really matter which we do, as long as we can find that there is a space there. Okay, so down here, oh, that's not a space. Off by 1. We actually need 8. So 8 is 4 plus 4. Nine is not defined because it was this one here. It needs to be 8. What was it? I think it was -E, and then you do this thing here, and it'll just run it for you. But I also need it to go to interactive mode. I think I just type hello here and we get that. Okay, so that's a space there. That should be okay. Which means then we can do, we can now have return console like this. And then we do the same thing here. We add this. Let me do that. And so we can do function. Trying to get there. Autocomplete, please. Function. And we can call this function with that. Except we need to make this a space. Like that. And then just to make this read a little bit nicer, I think in this case it might actually be nice to do it this way. Sure. And then we can save this to a variable. So that is the console object, which means this should just work for testing. The console object that we get from here should be the same as the regular console, and so if we do a console, if we do a .log on it, it should be the same as well, we should see it in the console. Uncaught type error. Object console log is not a function. Okay. So what is object console then? Oh, right, because we need to call it. So all we did was create a function, but we actually need to call it to actually get it. Try again. I'm gonna move this over here so it's a little bit more easily visible. Alright, there's our console log. We do actually need to make log. So const func console log is equal to object console plus log. And now we get func console log is equal to, or calling it, and then is equal to something, hello world. Do we have the letters for that? We don't have an H. We also, okay, so we're gonna need to build hello world. Or to make our challenge a little bit harder, we can do this with punctuation. I think that's probably the way we should go. We have time to do that. Hello, comma world. I never know what the proper capitalization for this thing is. Okay, so it's capital W. We're gonna have to find these letters somewhere, and I don't know, where are we gonna find these? So how do we capitalize H? Who knows? How do we capitalize W? Who knows? We do have potentially string.prototype.to uppercase. But that requires more capital letters, and we don't have that. One thing we can potentially do is, if I'm looking over here, that it's not at. There is a way to get the char code at this one. But that also requires a capital C. However, actually no, there's no easy way to do this. I was gonna say we can do plus, but actually doing plus on a string turns that string into a number, which isn't quite what we're looking for. Can we get this punctuation anywhere? I'm not sure. Chat, by the way, if you have any ideas, please feel free to shout them out. we have this punctuation, or we have ways to get we have ways to get that kind of punctuation, but we don't have this punctuation. Ooh, however, we can find a way to get an array, because we can get arrays. So for example, if you turn an array into a string, like say for this one, we get a comma. So now we have to find a way to get to an array. And what can you do with arrays? How do you get arrays? I think you use object.keys. Keys is probably going to be shorter, but also doesn't matter. Values. We don't have some of these letters. I don't know where we can get a V. But I think we do have everything from entries. We don't have an I. But we can get an I pretty easily. So we're going to do object.entries. But we need to do it on something that has keys. Function.prototype. There's nothing there either. Object._proto. No, there's nothing there. Triple underscore? No. String.prototype. Nothing either. Okay. What else can we do? What else generates an array? It doesn't have to be on the object constructor. It can be on the function constructor. So on the function constructor, we have arguments, caller, constructor, display name, length, name, prototype, apply, bind, call, toString. Ooh. Well, we do have toString. So for example, if we do a function return console, right? This is a function that we had created. toString. Function anonymous return console. We don't have any comments here. Alternatively, we also have access to the string constructor. What stands between us and from card code? We need capital C's. So we gotta find a way to get capital C. And once we unlock that, then we should be able to create any character that we want. We have the string here. We have the string constructor, which then lets us do... Oh, actually, hold on. There's another thing that we have. Do we have the letters to do this? Return this. Because this unlocks a whole lot of other stuff. Like pretty much everything. So this here, inside of the function constructor, is the global object. Okay, so as a shortcut, we'll have a globalThis. Type of globalThis is an object. And then what? We have clear immediate, set immediate, but we need capitals for those. Try object catch E. The problem is E. I don't know if we're allowed to. I don't know if we're allowed to use I mean, I'm saying if I don't know if we're allowed to use, but I'm the one who made the rules. That try catch almost feels like cheating because it's binding a variable that's that is not const. So I would like to try to avoid using try catch if we can, although the rules don't strictly forbid it. But let's see what you have here. Object, and then call the object, so it's not callable. Console.log e. So this will give us object is not a function. Type error. Still doesn't give us a capital C though. I was looking at a different error that started with cannot. We can throw something. But yeah, we're gonna try to avoid try catches and should try to leave that as an option for later. So what else can we get? So we have a bunch of stuff on the global object because now we have access to that. Oh, we don't actually. I don't see a place where we can get an H from. Function, string, object, boolean, string, object. We have number, but that doesn't give us an H. Do we have enough letters for arguments? Okay, so one thing that we can potentially do is let's throw this up here. Function return arguments. This gives us an object. Let's just make that args here so we can explore it. So args gives us... Oh, what is an object though? Args plus a string, so turning that into a string gets us this, which gives us a capital A. But I don't think we actually have an A anywhere. Actually, wait, we might. Because if we have this, and turn that into a string, we get function anonymous, which gets us an A. Okay. We can make that, we can use an A for that. So const func sure. Naming things. So this is a function, or no, we can't use that. This has to be all the way down here. So stirfuncanon is a function. We call this thing plus some string that we don't really care about. So C. And then this gets us... Actually, is this useful? Do we need a capital A? I mean, I think we can use an A somewhere else, though. Oh, wait, no, we do need a capital A. No, I'm looking at the wrong one. Card code at... From card codes. You're right, because this is the thing, too. We will need an A, because we will need that. Okay, so this lets us do stuff with numbers. So const a is equal to func or stir func anon at, what are we looking at? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So finally we need the 9. This will be, say, 8 plus 1. Let's just double check that we have that we actually have an A here. Okay, so we do have an A. And so from that A, we can... Are we missing an F? I think we're missing F's to be able to do that. B to A, an integer, seems very powerful. Ah, yes, you're right. And we actually... Oh, we don't have a B. No, we do have a B because it comes from object. So B to A, from the global object, the global function, B to A being basically a base 64 encode. So we can do something like B to A of some number. This number will get turned into a string, or really anything here. Right, we get turned into a string and we get access to a whole lot of letters. Okay. And we know how to get B to A. Because assuming that we can find a B, which we can do function return B to A. And it'll just give us the B to A function. Alternatively, we grab the global and then we do B to A like this. I think if we're going to end up using more global functions, I think this might be a little bit easier to use. So got a function here. Const obj globalThis is equal to function. Where's my return? Return space. Do we have an I? I don't think we have an I. Function. Oh no, we do have an I. It's a string. Const I is equal to stir string at 0, 1, 2, 3. And so then we can build T plus H plus... We don't have an H. Okay, I guess we just build B to A then. And to get B, const B is equal to stir function, or stir object rather, at 0, 1. And we have T already, we have O, and then we need A, which we were going to get from here. This actually needs to go down further. Down here. B plus T plus O plus A. Gonna move this up here so we can see it. So our goals here are to build constructor, which we already have. It's got this function, we get bulk console log, we build return, build hello world, and to get that we need to build get the v2a function to do base 64 encoding. So that gives us access to a whole lot of letters. And so we have that, we have func v2a, and now we just gotta experiment and see what we can get. So v2a 0, which we have capital A. 1, 2, 3. We have a W. We have function. We have object. We have string. That gets us a C. And we already had a C. And what else do we have? We have number. We have R, S, E, which aren't actually going to be able to get us very far. What if we give it a negative number? That gets us to L. So the way base64 works is it's all sequential. It's based on the bit representation of the character. It splits it up into chunks of 3 or so. Like every 3 characters ends up being 4 base64 characters. And so you have an increase of 1/3 in your base64 representation. That also means that the letters you get are pretty predictable. So now we just have to find a way to get something earlier than that. So if we look at the ASCII table, and I'm going to create a new one here, man7 ASCII. If we are seeing the numbers at being an M, right, so then we just need to find something here on this side here. So if we're seeing L, actually that might not necessarily be true. So all of those gets us L. That gets us L. And we're looking for capital C, which is unfortunately probably over here. And we can't make those. Well then. Oh, that's not quite right. Okay, so let's look at this. What is the code for C? Capital C. Right, so that is hex 43, which if we look at our calculator here, hex 43 is in binary this. And so now we just need to find something that looks like this. If you split it up into, look back here. If we split this back up into things like this, we take the first 6. Is that right? We get the first 6. All 16 bits will be captured in the first 3. Last 2 least significant digits or whatever. 5-4. I'm not sure I understand how this works. Oh, right, because there's a table here. Right, okay. So actually, if we're looking for C, then we need to find something that has this. Which I don't think we're going to get in any character representation here. Because that is all over here. We're on the side that we can't print. If we can get toString, then toString 16 gets a C. Yes, okay. Capital S might actually be easier. Capital S should be easier. And I think that would be the string constructor plus this. Plus any string. Okay, so we now have a capital S. Can confirm it's possible, I don't know the best way. Yeah. Okay. So, well, this is a trick here. So if we have a constructor or any function, really, if you have any function, you can turn that function to a string, and then it'll have the name of it in the string. So what we can do, and we did that over here too. So we can do const string is equal to func func string is equal to func. Do we have the string constructor? Wait. Oh, well, hold on. We don't have capital S yet. Oh, but we do have we have the string constructor. Const func string is equal to any one of these, like c dot let's call it s, whatever, dot constructor. All right, so now we have the string constructor. And then we can do const s is equal to func string plus s, because we just need some sort of string. So this will actually be a stir func string. We turn that into a string, so we have this plus that. Now we just need to grab the s from here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 seems to be very handy here. And this will just be capital S. And we get stir func string from 9, position 9. And now we have a capital S. And so we can build const stir toString, because we already have all the letters for it. T plus O plus S, T, R, I, N, G. Okay, this opens up a lot. Because, as you said, we can do string.toString 16. Actually, how do we use this thing? ToString. Oh, number.toString. No, that's number.prototype.toString. You get a radix. So actually, it's 16.toString. 16, or some sort of character code. 16 would be A, B, C. Actually, what? 12. Except that's all lowercase. If you want to go, you're gonna have to go much higher than that. What is it? 26. Why can't I math here? 26 plus 10, 36. And then 0 to... Why am I struggling? I should just write this down. So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. And then the same thing, but uppercase. Yeah, it stops at 36. And so we subtract 1 from all these line numbers, and we're looking for C. Then we're actually looking at 38. So 38.toString gives us not quite that. Oh yeah, okay, no. Wait, if it stops at 36, then we don't actually get this. Man. Because 36 is... Yeah, the entire alphabet. Okay. Well, actually, no, hold on. We can get a capital N. Does capital N actually give us anything? I don't think so. Well, that's too bad. That's a good idea. We have a capital S, which, I mean, toString can still be useful somehow. Where else can we get a C? Or, it doesn't necessarily have to be a C. We can have, as long as we can turn a character into a number, or sorry, a number into a character, then we can do all sorts of operations. Number.prototype.value of is integer to exponential to fixed to precision epsilon max safe integer number constructor. I don't think we need this one. We have a capital B. Capital B is 1 away from C, but I don't think that's going to help us. So just for reference here, you can actually get all the letters somehow through here. There are ways to do that, but we're not going to look at that. So are we stuck with just trying to figure out a good string for base 64ing? We might. What I should be looking at are combinations. Capital S. Function. I think I already looked at these ones actually. GILNORSTU space. GIL. It's gonna take forever. I don't want to do this. Code point at. Hold up. Do we have a capital P? No, we have no way to turn this number into a character. That's the problem. We can get we can maybe turn characters into numbers, but we need to find a way to turn them back into characters. Repeated application of v2a gives us all of hello world within a couple of cycles. So that is possible. Yeah, that leaves us without an exclamation mark, but exclamation mark, is that actually difficult? Hold on, wait. I wonder if you're actually being serious here. How are we not seeing any capital C's? There's a capital C. I mean, we could just do that. Now what's the soonest that we get a C? I think it's this one. Yeah, if you do this enough, it eventually gives you a C. But just okay. So we may as well just do that. So capital C. Do I still need this one? Func string. I don't remember what this was for. But we have B2A. Const C, capital C, is equal to, that's highly objectionable. Yeah, that's a good one. B2A, func B2A. Func B2A. This is 1, 2, 3, 4, 5, 6, 7. Make sure I don't miss any C's here. 8, 9, 10. Is it 10 before you get a capital C? 11. I'm gonna redo this one. A is equal to A. A is equal to B2A. A. And then A dot string contains, I think it was. Includes. No, I think it's includes. Includes C. A dot includes C, the capital C. And then this should give us the counts plus plus. Counts is equal to 1. And eventually we'll get there. Oh, we got a true here. Counts. 13 times before we do this. Okay. We do a for loop. No, we can't do a for loop. Because that requires using let variables. We can't do a function because that would mean we create a value that's not derived from. I mean, we technically could. No, that's fine. We'll just do this 13 times. Just like that. Now the question is, can we get this with anything shorter? Let's say we have a B, for example, or a C. We may as well try to experiment with a little bit, just so we don't have to keep doing that. But it looks like it's probably all going to be mostly the same. Unfortunate. However, B2A has C in it. Okay, let's try that. Ah, yes, okay, that makes a whole lot more sense. And because the string for B2A, so B2A as a string turns into the, I don't want to rely on that, hold up. Because that is implementation specific. But we can work with longer characters. So for example, BCEGILNORSTU base. And we can B2A this. And we're likely to have it in a couple of cycles somewhere. LIGECB. Really? But actually, you know what? If I was okay with using this has hardcode at directly, so we can just pull it from here. Except I don't want to do that. We have A to B. No, that's I don't know if that's going to give us anything because B2A console.log. That one gives us a C. Because that gives us native code. Okay, just gonna double check that we can actually rely on that. So we have Firefox here, which is separate from the V8 that Node uses. Dolphin Bird, welcome in. Folks love objects, yes. It's been quite the journey so far. We got all these letters, and we're trying to get to a capital C so we can do from card codes. We can build that. Actually, I'm not even sure if we have all the letters here that we need. We'll probably do. But yeah, we're trying to get a capital C from somewhere. And so far, our best option might be to turn console log into a function, or into a string, so we can run it through B2A, which is our base64 function. And I'm just making sure that this is going to be implementation agnostic. So console.log. Doesn't look like it is. Well, that's too bad. I mean, I can just say that this is meant to run just on Node, but I'd rather have it to be portable. However, function. Does this give us a Z? Function plus object. Wait, I can't even do that because that would be implementation specific. Ugh. How is it this hard to get a C? Okay, what do we have in globalThis? Can we do fetch, crypto, structured clone? You know what? Object.entries, globalThis. Can't believe this. Makes it so much easier. Because we can write entries, and we have access to globalThis. Oh wait, no, do we? We're missing an H, but I think an H is probably fairly easy to get. Function, string, object, boolean, false, true, 3. Anonymous. We don't have an H. Console. B2A, AA is an H. Oh yeah, because we do have. Okay, yeah, that's pretty simple. Okay, well, let's do that. We can construct an H using B2A. There's got to be a more classical way of doing that, though. So, for example, I think you can actually get an H using this, or not. I guess not. But func B2A of A plus A plus A const H is equal to this, and then we get property access at 3 gets us an H. Which means we get stir this is T plus H plus I plus S, because we have all those letters already. Which means const object globalThis is equal to function. Dream gaming. These rules are sick and twisted. Yeah. So some previous entries in our curse programming series, the first one we did was try to use as many npm packages as possible just to write a hello world and FizzBuzz. I think it might have been just FizzBuzz. And then the second one, I think we weren't allowed to use expression, or we can only use expressions, no statements. They were all similarly convoluted, but I think this one is probably the most involved yet. So we have function, and we get globalThis, and we do return space this, stir this. Okay, so now we have access to globalThis, which means we can do all of these. So const stir entries is equal to E plus N T. What am I doing? Entries like this. Entries like that. And then we can get const func object entries is equal to object at entries. Actually, I can probably just call it like that. It's going to be a little bit easier to for reference. So now we have object.entries, and we can call it with globalThis. So now we have all of the entries in globalThis, plus all of the functions that it allows us. Okay. now we got power. Because it means that now we have the strings of each of these. So we can get something like structured clone, or see what else can we get. Oh, actually this isn't going to... Hold up. We do have them all as strings. However, we need a way to iterate through these that is still deterministic. So we're not quite done yet. We got to figure out how to do that. Okay. So if we have this, do we have something like starts with? Do we do structured clone? We do have a capital. I think we can get a capital W from somewhere. Okay, can we get a length? Do we have the letters for length? L, E, N, G, H. And we got H here. And then T. H. So we have length. Developer man, welcome in. I'm building Windows clone JavaScript to prove a point. That's it's quite the feat. Good luck with that. There was one point where I wanted to build a Windows UI in JavaScript, and that just never happened. And now with the tools that are available with all the front-end frameworks, it's not actually that hard. So I kind of lost the interest in doing it. But maybe one day. Probably never, though. Symbol. We don't have a Y. Actually, symbol isn't going to help us do anything either. So yeah, what we're doing here, by the way, is we are restricted to using just the object constructor and anything derived from it. And so we have to build all of this stuff ourselves. And right now we're trying to figure out how to get a capital C so we can turn numbers into strings. Joking, but I'm actually building a scraper right now. It's the most fun programming niche I've tried so far. Yeah, I've built a scraper before. Nothing serious, but it is interesting to... Actually, I've built scrapers in Bash mostly, not JavaScript. But scrapers are fun. I don't know what is... Actually, hold up. We might be approaching this wrong. Because we do... Oh no, we still need a capital C. I was gonna say to uppercase. Except that requires a C. So if we can't use that, then add end includes index of. Hold up. Can we use regexes? No, I don't know how to construct a regex. Never mind. Concat. No, that's not gonna help. A code point at turns a non-negative integer to Unicode code point. does this give us, no, this gives us numbers. B to A object plus A includes C. Platform independence. Okay, B to A object plus C. So object plus C gives us this thing. Okay, sure. Or object plus A rather. Well, I suppose it probably doesn't matter. So this I definitely know is platform independence. Then B to A gets us this. Okay, great. Yeah. But we do need the string there so that we can turn it into a string. However, we do have access to the string constructor now, so we could in theory do this. But it's a little bit easier to just concatenate with a string. Okay, so finally on our quest to get C, we have that. So thank you very much. We can now get C. Const C is equal to func B to A object. Actually, wait a minute. B to A turns things into strings already. Yeah, just that. Alright, 529, welcome. It's not welcome in. Thanks for dropping by. You've been a big help. Hopefully we can get by without you. But yeah, and enjoy whatever you need to do, and good night. Okay, so we can get B to A with the object here, and so that gets us C. If we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, yet again, we can use the 9. And so just to make sure that we have that, that does indeed get a C. Okay. So from there, now we can construct from car code, because we have all these, I think we have all these letters. We have the string constructor somewhere. Func string. Then const stir from car code f plus r plus again, why am I doing this? We can do this. And then func string from stir from char codes. All right. So now we can turn numbers into strings. Func or string dot from char codes say. I don't actually know what we need here. Do we actually need more stuff? What are we looking for? Right, so we were trying to build hello world. Hello world being this here. So all we need now is to come with the numbers that correspond to these characters, which is fairly easy to do because we can look that up. So capital H is 72. A comma. I think we could have gotten somewhere else, but we can grab it from here. Comma is 44, and capital W is 87 or 50. Yeah, 87. So we'll start with capital H. So that's 72, and 72 is. If I can math correctly. Is that 8 times 9? Yeah, I think that's 8 times 9. 8, 9 times, yeah, 72. So, const h is equal to func string assert from char code. Actually, I may want to save this somewhere. Const from char code. Func string from char code. Is equal to that. Okay. So from there, we can create a bunch of other letters. To start with, we're going to do H. I'm going to move this out of the way. And then H is 8 times 9. Okay. And just to make sure that's correct, 72. We got an H. Very good. And then const comma is equal to, what did we say that was? So the thing we said that was 44. Yep, 44. That is going to be make sure that we actually use the variables that we made. Func string from char code. Comma being 44. Do we have 10? I don't think we have 10. Let's make it 10. That's 5 plus 5. Const 11 is equal to 5 plus 6. You know, obviously we can make these we can make these in any number of ways, but let's do that. And so then we have, I can't even find where we are. Comma, and we want to get to 44. So that is going to be 11 times 4. Okay, so now we have a comma. And then we const w. We'll look over here. W is this here, 87. How do we get to 87? That's 90 minus 3 in one way. So func string from char code, 9 times 10 minus 3. Okay, so I think that might actually be enough to log out hello world, and then we can clean this up so that we only get to the parts that we actually need. So I don't think we actually need this entry stuff anymore. We have console log. We have, I think we have all these. Actually, do we have L? We do have L. Okay. Hello. Plus comma plus space plus WORLD, and we also need an exclamation mark actually. Const exclamation. That would be number 33, so that would be 11 times 3. Func string char code 11 times 3. Okay. Plus exclamation. With all that, I think that now gets us to hello world being printed to the console. object-oriented programming if it stopped messing around. Yeah. Oh, right, because I need a plus here. Oh, on the topic of object-oriented programming, I actually do prefer... I know there are some people who don't like JavaScript's prototypical inheritance, but I do think it's actually better. And because you can do anything... So there are two types of object-oriented models. There's classical inheritance, which languages like C++ and Java and C# and all those languages have. And then you have prototypical inheritance, which is what JavaScript has. The difference is that with class-based inheritance, if one class is a subclass or inherits from another if the classes inherit, which means that the specific instances are all they can't really interact with each other. Whereas with prototypal inheritance, one object is a direct, let's say, ancestor of another object. So changes in one object will result in changes in anything that inherits it, which can lead to some interesting applications. Although it doesn't get used, probably doesn't get used to its fullest extent. We have hello here, F is not defined. Missing a discussion about OOP, yeah. I have stuff to say about OOP, but I feel like I can't express it properly. Maybe one day we'll do a deep dive or something into the various paradigms. Okay, so we're actually missing an F. But F is pretty easy to do. Because now that we have from character code, it's kind of cheating. But it does make it easy. Actually, no, hold up. We can get that a little bit more classically, because we do have function. So we're going to do that from here instead. So this is 0. Yeah, I was telling a friend the other day that I think languages are starting to move away from being object-oriented, which is probably a good thing. M is not defined. Do we have an M? Can we get an M from somewhere? Function, string, object, booleans, object, number. Type of plus object. And then we can get 0, 1, 2. Const m is equal to string number equal to 2. Then have you done functional stuff like Haskell? I do like functional programming. Haskell I have touched in one university course. But haven't really worked too much with it. I've done a bunch of rackets. What else? Yeah, I like rackets. And then for JavaScript code, I do tend to write in a more functional style, although not strictly. Also in that university course, we did ML. I've done, what other functional languages have I done? I've done a few. I know I've done a few. But I do like the functional style. And yeah, I guess come to think of it, the expression challenge that we had for the last course programming was an exercise in pure functional. Okay, so that's... Wait, why do we... M is not defined. Why do we need an M? Where is this from? 59. No, that's not quite right. D is not defined. Okay, so we don't have a D. I don't know where we needed the M for, but Okay. So where can we get a D? Function, string, object, boolean number. I guess we can just make it with from car codes. Uh, 100. That's 10 times 10. Constant D is equal to func string from char codes 10 times 10. Gonna move this down here. Surely there's a better way to do that though. Cannot access D before initialization. Cannot access D before initialization. Where did we do that? 61. Oh. Wait, then how did we... Hold up, are we actually just missing D? I think we're missing a D, which means we might have to do a B2A and get D from somewhere else. Which isn't that difficult. Okay. So something in B2A has to have something. We can reuse what we have here. Because this one does have a D. 0, 1, 2, 3, or 0, 1, 2, 3, 4, 5, 6, 7, 8. Constant D is equal to func B2A, object, and 8. Yeah, in terms of paradigms, I think my favorite paradigm is probably logic programming. So that's languages like Prolog. We actually did do a Prolog stream. It went kind of terribly because I didn't prep enough. I would like to do another one where I prepped a little bit more. But I really like how you can just tell it what you have and then tell it what you want and then it just gives it to you. Alright, so we have D here. And I think that should be everything then, if that's the case. It's not a function. Because 64. Did I spell it wrong? FROMCHARCODE. That is a function there. And then this is the same there. I'm just going to do a little bit of debugging here. Stir from card code, string, stir from the pair codes. And then we expect it to fail there, so that's fine. From undefined, a whole lot of undefined. Why is that? Why do we get undefined? FROM, we don't have a capital C. Oh, right, because we need to call this thing. We need to call... No, that's not right either. Huh? Func B2A, so B2A, A, right? That's what we have there. Ah, because I didn't call the function that actually generates it. Okay, that makes sense. So here, if you missed it earlier, we have the function constructor doing an evaluation of a string that we do. So this will be return space b2a. But then to actually get that result, you actually have to call it. And all we did was create a function that would return that would execute this code, but we didn't actually call it. So once we call it, now we have the function b2a. And so we actually all just needed to do that. And then now hopefully this will just work. Entry is not defined, which I don't think we actually need. We're going to keep this around for later, but I don't think we actually need that. And there we go, we have hello world after, what is this now? Been almost 2 hours. I don't know if we're going to be able to get to FizzBuzz. I kind of still want to though. Because it's a bit of a thing in this channel to do FizzBuzz in the wackiest ways. But FizzBuzz comes with its own problems, because now we have to figure out how to loop and stuff. So maybe we actually do save that for another stream. Okay, so let's clean this up. What do we actually need? I think we do need all of these numbers. We need all of these here. We have constructor, which we need to get the function constructor. The string to get the string constructor, so we can do stuff like this. So we can get capital S. And then toString, so that we can get, as we use capital S to do toString. And do we actually use this anywhere? No. So we don't need this. Func anon. So this plus C, so we can get an A because it says anonymous. Hold up, is this even... Is this portable? I know it's being blocked by CSP, don't worry about that. Okay, so that's portable, that's good. So, otherwise we'd have to redo that whole thing. That hello world mattered, yes. Okay, so yeah, going back from the top. So we created booleans, which we may or may not have actually needed. But we created booleans from object, and then we created numbers 0 and 1 from those booleans. And then through addition, we created a bunch more numbers. And then we use a type of operator to get function, string, object, boolean, number as strings. Because this is a function, this is a string, this here is an object, because we create an object here. This is a boolean, this is a number. The plus operator turns everything into a number. And then cursor object. What is this? Object plus function. Do we actually use this anywhere? Do we do capital O? Oh, we get the space, right? So it doesn't actually matter strictly what this is, but we do need this space here. And so from all of these strings, we get a bunch of letters. And then from those letters, we spell a constructor, which then we make into to get the function constructor, which gets us our eval. And then from there, we also got the string constructor, so we can make strings. Well, actually, we don't actually create strings. We use it to get a capital S. So func string, and then string 9, so we get the capital S. And then we use the function constructor to create a function for the anonymous, we can get the letter A. And so from there, we get the very powerful b2a function, which gets us base 64. Using the function constructor as an eval, as we can see here, we return b2a to get it from the global scope. And then we call it, very important to call it. And so now we have access to b2a. And from there, we ended up doing some random stuff, just figuring out what strings could get us which letters that we're missing. So in this case, we had a string of 3 A's, B2A, AA, and then the last character of that gave us an H, and also an object like that. Object. Hold up. Is this portable? I'm confused. Why does this give us... Oh, right, because it's object, right. Okay, that's what that is. So that put through B2A gets us this string here, which then we can get a capital C out of, and we can also get a D out of. And so from that, we can spell out from card code, which is a very important function to let us turn numbers into characters. Give me an idea. I will answer that in a bit. So let's just finish this one first. So from there, we can get the from character code function. I'm going to do it this way. And then we have, from there, we can just turn numbers into characters. We get H, W, comma, exclamation. Those are the ones that we're missing. This we actually don't need anymore, but I will save that for later. Oh. And then entries we also don't need, and then globalThis we also don't need, but it might be useful for some of our other ones. So from there we have the console object, which we do the same eval technique here. Then we get console log, which we actually could just use. We can get a dot from somewhere, but like using this, but it's fine. And then from there we just console log out the string that we had to create. And there we go. We have hello world using just the object constructor. So yeah, what gave me this idea? That was a very good question. I know there was some similarity to this language here, but it wasn't really this that gave me the idea. So I got the idea last week, or earlier this week, and yeah, I was good question. Even I don't know anymore. But yeah, I was thinking of oh no, it was at work. Somebody was asking for help, and we came across something, and somehow this triggered some sort of restriction. So I've always been coming up with ideas for curse programming streams like this, because I want to do more of these. And somehow I got the idea to restrict it to just a single value, and in this case the object constructor. And I think the phrase everything is an object in JavaScript is what triggered it, because we had talked about something about objects. And so, you know, taking it to the extreme, it's the joke is not, or rather it's not really the object constructor like the title in the stream, but making it the object constructor makes it a little bit more, in a way, more difficult, but also in a way more flexible, because it means we have access to a whole lot of other things. Because if you restrict yourself to just the like an object literal, which I was thinking of, actually for certain variations of this, I was thinking of maybe just doing undefined, which would be I think even more challenging. You can still get your booleans, but that makes it a little bit more difficult because you don't have... Oh yeah, and you can still get your type up, which means then you can still get your string constructor somehow. But yeah, there are ways to do it, but I ended up landing on object so that it fits with the meme. Everything is an object in JavaScript. Yeah, that's more or less how. So if this kind of stuff interests you, I don't do this very often, but I do want to do more of it. The way I describe this is like, have you ever heard of Uwo's lab? It used to be Uwu to Oo. I'll give him a shout out here. He does a lot of like science and engineering stuff, and in a way, it's kind of like what we're doing here. Like one time, he had done like, what was it? Dispensing bacon from a hand dryer. Or things like one time, the first one that I came in for was an electric piano, but the keys and or the sounds was made from electricity, or other crazy stuff like that. I think most recently he had done a seafood boil in his bathtub. But yeah, I don't think he's alive right now, so unfortunate. Okay. But yeah, if you're looking, if this kind of stuff interests you, I do want to do more of it. Go check out my YouTube channel, because most likely I will be doing more of those there rather than in Twitch. But you know, I might reconsider that. Most of my streams are on YouTube, and Twitch is more of a special exception on certain cases. Although I do find that I've been streaming more and more here. In the meantime, while I'm killing stuff, well, how much time do we have? Yeah, I don't think we're gonna do. We're gonna save FizzBuzz for another time because I think that's gonna take another 2 hours, and I don't want to go for 4 hours. So I think Hello World is going to be where we leave it today. I will be pushing this up to GitHub. On the YouTube side, the link is in the description. And on the Twitch side, the repo is pinned in the chat. So you can have a look at it there. Discord, yes. I do have Discord. YouTube, the link is in the description as always. And on Twitch, there is the About panel. It's all linked there as well. Am I missing anything else? I think there was still a few more. But yeah, next week. So actually, this is the only stream for this week. Next week I will put out the schedule early next week as usual. I'm not quite sure what we're going to be doing, but I'm sure it'll be good. So just watch out for that. As usual, it'll be posted in Discord and on Twitter and all that. Is there anything else? I think that's probably it. So yeah, thank you all for coming. This has been quite the journey. We'll do this again with FizzBuzz. And yeah, if you're on the Twitch side, stick around. We're gonna find somebody to raid. On YouTube, we're just gonna end because I don't have raids enabled yet. Gotta have more followers for that. All right, I'm very terrible at ending, but we're gonna end. Thanks everyone, and we'll see you next stream. And good night. Bye. Alright, so over on Twitch, I think I found somebody to raid. Actually, hold on, let me see if we can find somebody else. I can't believe this. Did I actually forget to... Man, I forgot to change the category. It's not special events. It's actually supposed to be software and engineering, or software and game development. Well, okay. That's fine. The Twitch doesn't save VODs anyway. We are going to go raid Soy Milk, his fellow programmer. Much enjoyed content. She's going to be playing Balatoro, which is not a game that I've played, but yeah, I'm sure it'll be fine. How do I raid? Raid that. Okay. Great. Raid messages. You can go copy that. And yeah, we will see you there. Right, chat.